Alright, here's a problem that kind of shows the essence of Newton's second law. Let's say we have three masses that are connected by cords like this, and then we pull on this whole system with a force P equals 60 newtons, let's say. And let's say that the masses are, well, let's say M1 is 10 kilograms, M2 is 20 kilograms, this is just to make it easy, and M3 is 30 kilograms. The question, what is the tension T1 and what is the tension T2? We know what the tension right here is, that's 60 newtons. So how do we figure out what T1 and T2 are? Well, first of all, we need to write down Newton's second law for the whole system. In other words, all of these masses are being accelerated to the right by this force of 60 newtons. So we can write that P, the net force acting on this, we're assuming no friction here, is equal to M1 plus M2 plus M3 times the acceleration. So that means then that the acceleration is equal to P divided by the sum of the masses. And I'm just using some notation here to indicate that I'm summing up the masses. So that's equal to 60 divided by M1 plus M2 plus M3, and that also turns out to be 60. So this is equal to 1 meter per second squared. And this is just to make the arithmetic easy. Now that we know what A is, then we can figure out what T1 is. Look at the forces that are accelerating masses 2 and 3. Mass 2 and 3 together are being accelerated by the force T1 in this direction. So we can write that F net, which is T1, is equal to M2 plus M3 times A, and that's equal to M2 plus M3, that's 50 times A, which is 1. So T1 is equal to 50 newtons. And similarly, T2 is accelerating mass M3, so that's equal to M3 times A, and that's equal to 30 times A, and that's equal to 30 newtons. And that's how you do it. I've chosen the arithmetic to make it simple, almost trivial. But anyway, that's how you attack such a problem. Look at the forces acting on the mass that's being accelerated. Usually you have to figure out what the acceleration is first.